Hey everyone, welcome back to the channel. It's been a little bit since I did a video showing my Fallout inspired show module that I take to train shows. And when I posted that, and then at the show that was just after the video posting, I was asked if I could do a behind the scenes video showing how I made the elevator work on my Fallout shelter. And as I'm between projects right now, I figured that it would be a good time to get the video made up and posted. And hopefully it will be informative and can help other people that are looking to incorporate an elevator into either their layout, module, or other project that they may be working on. I'll get to the technical side of things in a little bit, but let's go over what you'll need to have to make this work. The first is you will need to have a slight understanding of coding and how Arduinos work. I'll go over the code that I use to make it work and some of the spots that you can tweak if things aren't working quite right for you. But as I also have a limited understanding of it, I'm not the best person to ask if you've got very technical questions of Arduinos. As far as that goes, you will also need to have an Arduino to make this work. Either an Arduino Nano, Uno, whatever you want. I only use this Arduino to make the elevator work. The rest of them that are there that you see are used for other things on the module, and I've included a card. If you want to see what those are, you can click and watch that video. You'll also need to have a stepper motor and the driver board for that motor. When I first was getting into this, I bought this kit from Elegoo, and this was years ago, so I don't know if it's still available or not. But it has 5 motors and driver boards in it. I went that route because I knew I wanted to add a second elevator at some point and figured this was the cheapest way to go for the time being. You will need to have a computer with the Arduino software installed on it. And then most importantly, you'll need to have whatever you're going to put the elevator in. In my case, it's this Fallout shelter. With those requirements are out of the way, let's get into the digital process of the code and what it does. And then once I'm done with that, we'll come back and show you, more of the shelter and the things that were hurdles that I had to overcome with working in 1 with N-Scale and 2 just the stepper motor in general. So let me get the computer set up to start recording that, and we'll be back in a bit. Okay everyone, here is the sketch that I use for the elevator in the Fallout shelter. I don't know if I've said it before or if I didn't say it in the video showing off the Fallout shelter to begin with, but this program just takes the elevator, goes to the bottom of the shaft, and then goes up to a random floor, back down to the bottom, and just repeats itself. If you want anything more robust than that, unfortunately, I'm not going to be able to help you with that, as this is pretty much the extent that I have with knowledge-wise of this elevator. When I was searching for this, there were 2 things that really helped me out a ton. That being finding the homing code from Ivan at Brainy Bits and the inclusion of the Excel stepper library that was created by Mike McCauley. You will need to install this library, the Excel stepper library, on whichever computer you're running Arduino on. There are plenty of tutorials showing how to do that, so I'll bypass this, in sake of time, and it is a pretty easy thing to do. The first thing that you need to set up, or at least that I set up, was the pins that the Arduino was using to talk to the stepper driver board. And this is how I had to configure it to work with my board. There are differences in some of the boards, so if you buy a different one, it may be different, or it may just that something's different and you have to change it. It's kind of a trial and error thing, looking at the diagrams on for your stepper board, but for the most part, at least mine, this is what works. Then I also needed to define what it was going to be the home switch, or the piece that tells the stepper board and the Arduino that this is the home position or 0. And in my case, I'll go over it in a little bit when we get back to the shelter, but I use just some wires glued to the bottom of the shaft and then some copper put up underneath the elevator car that acts as a switch in a way. I do want to try a micro switch, as you can see in my notes, but where this is working, I've been hesitant to change anything, because if it's working, why change things and then have it break? The next thing you'll need is to have a variable to see if the move to and from a floor has been completed, if the homing of the stepper motor has been completed or not, and then in my case, a variable that just says bottom, as that is where my spot is at, is the bottom of the elevator shaft. I'm not sure with the serial begin if that's needed or not. Normally I know that's more for displaying things on an external display connected to the Arduino, or showing information down here. It may be needed. I just haven't looked into it further if it does. And again, if it's working, why break it? Then I needed to define the home switch as a button inside of the program, so that's what that's for. And a delay is inserted as well to make sure that everything is initialized the way that it needs to be before starting anything with the Arduino and the movement of the stepper motor. And then you need to define how fast you want the stepper motor to go, and then how fast it accelerates to that max speed. As it says, the slower is very much better in terms of accuracy when you are homing the motor or going to the bottom of the shaft. Unfortunately, with N scale and size constrictions, I had to go a little bit faster to give a little bit more pressure onto the wires for, saying that yes, I'm at the home position. But, that's a trial and error thing for you to see what works for your setup. Then we get into the homing of the stepper motor. This says that it's moving it counterclockwise. Unfortunately, I don't know if it's counterclockwise or clockwise, because when I've been doing some tweaking on the shelter itself, the cable attached to the car would get strung differently on the spool that I have, and I had to make changes on the fly, and I can't remember which way is going clockwise and which way is going counterclockwise. But it's easy to change that just by changing these minuses to be pluses and then these pluses to be minuses, and it'll either go clockwise or counterclockwise. The only thing you need to do is make sure that this line, or these are opposite of what this line is. So if you've changed this to be pluses, you need to change this to be minuses down here. And that's really all you need to do. and you may want to change those anyway, wrapping the cable differently on whatever spool you're going to have, or whichever way you've mounted your stepper motor to, you may need it to be counterclockwise, and I have it going clockwise. It's just trial and error. Again, this is just a thing of, or for this is once the button is pressed, it will start to go up the different direction. And so in my case, it goes down to the bottom, presses the button, and then to tell it that that's 0 for sure, it rises up just a little bit to come off of the button, and then that becomes the actual, homing is 0. And so that's what this does, and why it needs to be opposite is that the elevator will either go down and then it needs to move up a little bit, or it's going clockwise to go down, hits the button, and then it needs to go counterclockwise to go up just a little bit to, give the Arduino the right variable that, okay, you can start the rest of the program. And after the homing has been set, and that, this is 0 position, you can change to be a different speed on the stepper motor. For me, I found that this was the best speed variable for N-scale, and that it would go up in a speed that wasn't too fast, wasn't too slow, but it also gave it enough interest for people that would be watching to stay and watch it. Again, you may need to increase it if you go to a larger scale. Again, this is, I'm working in N, but unfortunately there isn't any set number. It's just trial and error for what you like. Now, this line here is more set with my coding and the way that I have my elevator working. And that is that these numbers here correspond to the floors that the car goes up to. So my height to the first floor is 4,500 steps. The second floor is 6,650, and so on. If you want it to just go up to a spot and then back down to a spot, you can get rid of this line and just put in a number in between these two parentheses. Okay, sorry about that. I had numlock turned off, and it messed with some stuff. But in this case, if you wanted it to just go to the top and then go back down to the bottom for, and what I have set up, you would just put in that number and it would go, to the top and then back down. But I want to keep it this way just so I don't mess with my code. The other thing with these numbers is it's going to be dependent on how you have your elevator set up. It's going to be a lot of trial and error until you find that for sure. And the best way that I've done it is copied and pasted this and created a second sketch, and have actually just removed this line completely so that I just had, this line, and then I would put numbers in here and just keep trial and error until, I came up with whatever floors I wanted to do. Or if you want to just copy and paste it, you can add the slashes into it. And for those that don't code, that just tells the Arduino to ignore it, that it's just a note. And you can do that pretty much anywhere, but anything after that is seen as a note. And as I was looking at it after the little hiccup, I noticed I had, a second set there that was just redundant. So I already removed those for that. The other thing is if you want to have more than the 5 floors, it's just an easy thing, adding a comma, and we'll just put in a random number, and that becomes the next floor. And you can keep doing that with as many as you want, and it doesn't really matter. Once you get that number to however many you want, you then need to go back and change this to be whatever. So in this case, we just added 1, so we add 1 to that. The reasoning for that is this is seen as somewhat as binary. So this starts off at 0, then 1, 2, 3, 4, 5. So that's the reason for that. Pretty simple to add, whatever you want. But in my case, the 5 floors is working for now. Then it will move to that floor. Once it hits that point, it tells it to 0. And I've put in a 1 to 10 second random delay. I found that 10 seconds is about the max that you want to do, and that gives the interest is still there for the public or whoever would be looking at it, but also gives it enough chance of somebody getting on and off the elevator. Once that delay is up, it moves back down to the bottom floor, and then again waits a random amount of time and goes back up. So that's all that there is to that. Again, the big thing is trial and error for this as to however many floors you want, what number it is that the stepper motor goes up to. You can either, easy way, create a second sketch and just put the single number in here, or, make it a note. Whatever works for you, doesn't matter. So with that, let me get the fallout shelter back up onto the work table, and we'll go over that a little bit, and we'll see you all in just a bit. Okay, so here is the fallout shelter again. So for the homing button, what I've done is just put some wire up through the bottom of it. The bottom of the elevator car is just a piece of copper that I've folded into, or just wire that I put into a cube kind of rectangle and filled with solder. And then I've just put solder on the bottom of the wires down there at the bottom of the shaft, if it'll focus in. The one wire goes to the pin number 9 on the Arduino. Let me just double check that to make sure. Yep, it goes to pin 9, and then the other one goes to the ground that's associated with that Arduino. And that way it does act like the button and tells the Arduino what it needs to know. As far as the car and the shaft and going, keeping it somewhat straight, I just put a small wooden dowel up through it. And on the back of the car, you can kind of see it back there, I just put some polystyrene tube that fit around the dowel, and that keeps it somewhat straight, and then I don't have to worry about it moving around and causing issues. As far as the motor, I've just mounted it with some dowel as well and hot glued it in to keep it from going out of, or turning the way I don't want it to, or falling out, whatever you want that could happen to it. It helps prevent that. As far as the cable that I use and the spool that it goes up around, I had a blind that broke, and this is actually the piece that is on the bottom of the pull down cord to raise the blinds, and then the cable is actually the string from those blinds. And so just reused it. It worked for what I needed it to, and why throw it away? And then just put some hot glue on there to keep the string from releasing. And then as far as the board, here are the two power cables for ground and power. And then the pins going to the Arduino. And I just have some other cables that, I have that link together. I do need to get some better connectors on them and some better wiring, but I wanted to make sure everything was working before I move on to that step. So I will end this with re-putting in the clip showing the elevator working. And hopefully this was somewhat informative. It helps out. If you have questions, leave a comment and I'll try and answer them the best I can. Oh, the other thing that I just noticed and thought of is the way I got some extra weight to the car was I went and got some lead fishing weights and just painted them gray to look like barrels. And that's all there is to it. So I'll get that other clip playing. And again, if you have questions, leave them in the comments and I'll try and answer it the best I can. And we'll catch everyone later.